Welcome everyone back to the SEA Sailing Symposium on North Atlantic right whales. Chilly afternoon here on the quarterdeck of the Core with Kramer, and today we'll be hearing from Colleen Coogan, who is NOAA's Marine Mammal and Sea Turtle Branch Chief.
Thanks everyone, and thanks for inviting us, Craig, to join us for this sail. It's been a real treat, and thanks to the captain and the crew for tolerating and teaching and taking care of us, and not least the stewards for feeding us extremely well. Really appreciate it and have learned a lot being out here with all of you. So yeah, I'm Colleen Coogan. I grew up just outside of New York City on Long Island, born in Queens, raised just outside of that. And the ocean was where we went as a family to recreate. So we would go, any of you who know New York, we would go a 10-mile drive, large family jammed into our Ford LTD wagon, and go to Jones Beach for the day on the weekends. Anytime my father had a day off, mostly weekends. Spend the day in the summers recreating, body surfing, building castles, exploring. So as a member of a large family using a lot of resources, as I got older, I felt a stewardship for natural resources to kind of give back, and especially to the oceans. I really had an affinity for that. But went to school in the Bronx where I could afford to go to a college. They didn't have a marine program, and I really did not think I'd be able to go into marine biology. Got a job at the American Museum of Natural History taking care of unisex lizards, taking care of a lizard colony, doing some genetic work with people, and mentioned to them that I was trying to figure out how to get funding to go to school for marine biology for a master's, when a sea turtle stranding occurred out on Long Island, and we happened to have one of the renowned sea turtle specialists visiting the museum at that time. They went out, saw that the group that was responding to marine mammals and sea turtles out there was about to lose a research assistant because of personality conflicts that were very understandable once I got there, but told me there may be a job opening up, and I went got the job. I had to learn how to drive within a month, and a few months later was driving up and down the beaches of Long Island, New York, picking up small stranded cetaceans and seals, sea turtles, throwing them in the back of the truck, taking them up the island to do necropsies on them. And we also responded to large whale strandings. And they supported themselves with a whale watch at the end of Long Island. Now, living in mostly the city area, I didn't actually know there were whales or sea turtles off of Long Island as a kid growing up there. And so stewardship of the protected species really became a vocation at that time. I had been interested more in just overall marine stewardship. I went from that work to a series of awesome field opportunities. And then in 1989, I got a job working for NOAA Fisheries in what was then called the Northeast Regional Office. I called them my golden handcuffs because it was the first really secure job I had, came with a lot of security. And I've been with NOAA Fisheries on and off since. I did take a few years off when my kids were born, and I came back as a contractor at first, but worked my way up. I've worked with sea turtles and marine mammal conservation and recovery, as well as in some of the fisheries management components of the agency. So NOAA Fisheries is a part of NOAA. NOAA also has an ocean service, a weather service, a satellite service, and NOAA Fisheries is a part that's responsible for studying and conserving living marine resources. So it's fish habitats that the fish rely on. Marine mammals and sea turtles are protected by some of our laws. And our charge is, we don't make up the laws, that's done by Congress, but our charge is to implement the laws that Congress makes governing our ocean resources. The Greater Atlantic Regional Fisheries Office is where I work. It's in Gloucester, Massachusetts. We do the management component. I think I mentioned this the other day. The Northeast Fisheries Science Center, which is where Lindsay works from, they do the research. So we take the science and we apply it to implement the laws and to manage the living marine resources. And that's done, the science is done out of Woods Hole at the Northeast Fisheries Science Center. So I work up in Gloucester. The region extends from the North Carolina-Virginia border up to the Canadian border. So it's the entire Northeast region. For protected resources, those animals don't pay attention to the borders, so we work very closely with our friends in the Southeast region. In almost all the work we do, we collaborate really closely with them. Right whales are both an endangered species and a marine mammal, so they're protected by both the Endangered Species Act and the Marine Mammal Protection Act, and I'm going to cover a little bit of that now. And again, my role is really working towards recovering right whales is one of our primary conservation challenges. I'd say probably one of the biggest marine conservation challenges that my region faces. It's very complicated. We don't have all the answers yet, and the two main things I really would like you to take home is it is very complicated. We don't have all the answers, and it's a hugely collaborative effort. So I think you probably already heard me referring to information that I've gotten from the New England Aquarium, Amy identifying work that she's done that's helped us out. We work very closely with the Center for Coastal Studies as well. The work that Jesse does has informed what we do. Erica and I both go to the North Atlantic Right Whale Consortium meeting every year, and almost every year or every other year it's at Bob's museum in New Bedford, and then Lindsay's doing a lot of the work that supports a lot of what we do. So it's a really very collaborative effort. No one group knows everything. And again, so NOAA Fisheries is a part of NOAA, and our work is really to implement the laws that Congress creates. I say that a lot because people get mad at us sometimes for implementing laws. We don't write the laws, and we are bound by them. They are the fences that NOAA Fisheries works under. It's a little bit different than a private agency or organization that can research what they want to. We're bound by what these laws require. So you've seen this graphic or a related graphic already shared by Amy that shows the decline of the North Atlantic right whale. I'll actually pass this around. On the one that I have, the curve on the top is the estimated population size. The bar graph on the bottom, that's the calving, the documented calving numbers over since 1980. And so, as Amy mentioned, it peaked at about nearly 500 animals in 2010. The population has declined fairly rapidly. It really accelerated around 2017, but sometime between 2011 and 2013, the decline really started. So we're now down to probably about 338 animals as of the end of 2020. It always takes us 2 years to get a population estimate because we have to wait till we have all the survey results and work it into the model. So we are now down, in 2020, we're down to about where we were in 2001. So the 2+% growth rate we had seen early on has really been reversed, and now we're back to where we were in 2001. And of course, it came up since then, and it could come up again, and that's really what our goal is. If you look at the calving numbers, one of the big differences between now and what was going on in the early 2000s is now we've got very few calves being born. Our best year in the last few years, we had 20 in 321 in 2021, and we've gone, 20 was the average calving number from 2000 to 2010. 20 was the average, and that was our best year this decade. And we had 1 year where we had 0 calves. So in the past, for that population to grow, we really had to have more calves. Obviously, it's simple biology. And right now, at the time, we probably had 100 adult females, and now we only have about 70 adult females. So if it was possible to do anything, we would really love to, put a protective bubble around those adult females and help them with their calving. They used to calve every 4 or 5 years. Now it's every 10+ years. Quite a few of our recent moms have been, I think, 15 years old before we've seen them calving first. So they're calving later. They're not calving as frequently, and really calving is the only way to get us out of this.
That's what happens when you educate them.
Yes, that's right. Okay. And so since
70,
approximately 70 females, adult females capable of reproducing. This year we had only 12 calves. We were hoping, I'm always hoping for 30, 40. So only 69 new calves since 2017, and I'll explain why 2017 is important later on. Well, okay, I'll explain it right now. In 2017, an unusual mortality event was declared. NIMS declares an unusual, and I'll be explaining that graphic. NIMS declares an unusual mortality event when a rate of mortalities has changed, or a cause has been found, like an avian flu mortality just occurred in some seals, and so that was called an unusual mortality event. The reason we declare them is it allows us to bring extra resources and experts into reviewing the work around evaluating the mortality event. In 2017, what happened was 12 dead animals were documented in the Gulf of St. Lawrence, and we saw another 5 in U.S. waters. So that was a huge, 17 dead animals in 1 year was a huge increase in observed mortality rate. But on the graphic that's going around, you'll see the observed mortality and serious injury rates are in the bars on the bottom. A serious injury is a legally defined category, and it means that it's an animal that is likely to die from its injury. So the injury is so serious, from what we know from watching these whales, we know that that whale is going to die. Sadly, we sometimes call it a dead whale swimming because they just look awful, often die slowly in front of people over a course of a period of time. So I've added them to the mortalities, but one difference you see is somewhere in the early 2010s, the number of observed mortalities, serious injuries and mortalities is well below the estimated. So the population estimate is capable of, and it's a peer-reviewed population estimate following a process that was published in 2017. But it departs from the observed. Up to 30% of these animals are dying without us ever seeing them. We don't see the carcasses. We don't know exactly what they've died from. And that was very alarming, really, to all of us. We're hoping that now that we know where, as Amy and others have mentioned, the whales have changed their distribution. We are looking in other places now that we know where to look for them. We're hoping that we can kind of bring those numbers back together again, and at least we'll have some more data on what's killing them because we will have the animals. We will be seeing the animals. Did you have a question?
So the curve is departing because there was a method to predict it, and so is it possible before 2017 it would also...
They hindcasted with the model. So yes, all of the estimated mortalities were using the same model. The reason that sometimes there's more as a serious injury might be next year's actual mortality. So while I'm putting them down in the same years we observed them, in some cases there'd be a mortality later on. And then again, it is an estimated mortality. It's not necessarily exact. As I mentioned, since 2017, there have been 69 new calves. There have also been 69 serious injuries and mortalities. So that is a no net gain since 2017, unfortunately. The observed mortalities, where we have been able to tell or at least look at them, there were quite a few unknown, especially in Canada. 2017, they weren't expecting all those mortalities. They didn't get to the carcasses until they were too decomposed to tell what was going on, and that a couple of those happen every year, where by the time we see a right whale, a dead right whale, or a dead any large whale, it's too far gone for us to do much. But there have been 12 killed by vessel strikes during that time, 9 entanglements, 2 perinatal mortalities. Those are probably natural mortalities. An animal dies as it's born, or right before it's born, or right after it's born, as with any mammal. That's not that uncommon. With the serious injuries, 30 of them have been entanglements, 2 vessel strikes, 1 dependent calf. That was a calf that was not struck by a vessel, but it was a calf that was not entangled, but the mother was so badly entangled it was not going to be able to support that calf, so we count that as a serious injury. Both of those have probably died. They haven't been seen since. There have also been 28 sublethal injuries, and those are the injuries that are bad enough that we're tracking them over time to see if they become a serious injury or mortality, or if that animal disappears and we assume then that would be a mortality. We wanted to see if we could find any patterns to what's going on, or changes in patterns as the distribution has changed. And so we're looking at the difference in the incidence in the 2 different decades and see whether or not the pattern has changed and what's killing them. Again, I'm going to pass around a graphic on this while I'm explaining it. So two things we know. The first 10 years, there were fewer incidents. These include non-serious injuries, but there were fewer incidents than there were after 2011. So the first decade wasn't as bad as the last. It's gone up almost 150%. The entanglements remains the most types of, so entanglements are the first bar in both decades. And non-serious injuries are green. Both have gone up, both the mortalities and serious injuries and the non-serious injuries, but a lot more incidents in the second decade in the more recent time period. Yes?
What do you consider non-serious injuries versus serious?
Serious is going to die from it. It depends on, so there is a protocol that's published about how they look at it and define whether it's serious. So based on what they know from past mortalities, injuries that have caused mortality, they define it as serious or non-serious.
Like vessel strikes? Or...
Some vessel strikes might not be a serious injury, some are. So it really depends on the severity of what's happened. So things like an entanglement that wraps a tailstock is worse than an entanglement that's draped over a flipper. Okay. And I mean, that's maybe oversimplified, but a little bit. So, and these are not all happening in the U.S. This animal is transboundary. We know it spends a lot of time in Canada. A lot of them spend a lot of time in Canada. A lot of them spend a lot of time in the U.S. And some occasionally leave us both. So we did want to look at the difference in the first decade by country. And in the second decade, we're seeing a huge increase in unknown mortalities. So they may be first seen in one country or another, but we don't know where the injury was picked up. Canada is in yellow, and you can see the number of incidents reported from Canada has gone up greatly in between the two decades. And the U.S., the number what we know has been caused by a U.S. incident, the number has gone down in the 2 decades. The sample size is so small, it's hard to know if it's significant, but you know, we know that there's a lot we don't know, there's a lot of unknowns, and that the injuries and mortalities and incidents in Canada have gone up a lot in the second decade. So we are working with Canada. We work with them frequently, trying to make sure that they're implementing the same sorts of conservation measures that we're implementing here. If they learn anything new, they'll give it to us. We'll tell them the same. But we really do try to keep the pressure on Canada, because the animal is not going to recover unless recovery happens on both sides of the border. The fact that a lot of those mortalities and serious injuries that are causing the population to decline are occurring in Canada does not absolve us from the requirement for us to get it down in the United States. Under the ESA and the MMPA, we're still required to do our best on our side of the border. We did look at trying to break down the deadly interactions range-wide. It just tells us very similarly. The vessel strikes are down on the bottom. They haven't really changed that much in rate. There are still too many. We still need to get the number of vessel strikes down. But when we look at the serious injuries or mortalities that are caused by entanglements, you can see that rate, as Amy mentioned yesterday, has gone up quite a bit. If you look at dark blue, those are the confirmed Canadian cases. And if you look at the only ones confirmed U.S. take are the dark black, almost black color. Most of them we can't tell where the gear on the animal came from when there is gear, or where the entanglement scars and injuries came from when it's just a scar or injury. I could pass that one around too. We'll leave these in the science room if people don't really want to look at them now. That's okay. So I do have examples of what in recent years many of the animals have no gear left. They just have the injury. I think about half of the animals have gear on them, and about half of the time we can get the gear from them. We can get some rope from the animal. A lot of the times we can't even get rope from the animal. Either we see the animal, what happened up the Carolinas this year, a right whale was seen with a very serious looking entanglement. The whale was in really bad shape. It was seen on an aerial survey. Nobody could get out, and the whale was gone, and we haven't seen it since. That whale, no one has a piece of that gear. Unless it washes up, we're not going to be able to tell where that gear was from. So I do have an example of three, just to let you see why it's difficult, three samples where we were able to get some rope. One is from a minke whale, one is from a humpback whale, and one is from right whale named Cottontail. And you can see gear marks on a couple of them. On the minke whales, there's a little bit of purple rope. On the humpback whale, there's a red rope. On Cottontail, we are fairly certain that that is Canadian gear, Canadian snow crab gear. It is hard to see any gear marking on it, even though they are also now required to mark their ropes to try and distinguish it. But in the Canadian gear, we are seeing more that we can identify as Canada. It is also more identifiable, so there's a little bit of an observer bias there. The Canadian gear has what appears to be a commercially created splice in it. And it also, they're using line that has a beaded lead line in the middle of it to help it sink. And it's a very expensive, large diameter offshore line. The Canadians are claiming that they think Cottontail, or some of them feel that Cottontail has marking on it that looks just like what a black sea bass fisherman might use, the marks that are required in the mid-Atlantic black sea bass fishery. But a black sea bass fisherman probably would not be, I mean, we don't think they would be buying such expensive line for their fishery. They don't need a line that heavy. So we believe that this is, that type of line is really indicative of Canadian line. So as I mentioned, right whales are an endangered species, and I'd like to do a shout out. This is the 50th anniversary of the Endangered Species Act. We'll be celebrating that, I hope, this year. Because they're an endangered species, we're required to implement a recovery plan to promote recovery or to help the population recover, and they've been under a recovery plan for years. Every 5 years, we're required to report to Congress on our progress. We do a 5-year review. It summarizes all the new information since the last one was put out, and we have to identify whether or not we think it's still endangered, or whether it should be downlisted or delisted, and then we also have to identify what the priorities are for the next 5 years. So a lot of what we found in our 5-year review is similar to what we've already heard from Amy and others. Low rate of reproduction, longer calving intervals, declining abundance, shifting distribution, increased transboundary movement, and the risk that comes from that increased movement. So really, right whales moving up to Canada before they had any protections in place took a lot of right whales out in 2017 and a number since then as well. Lower overall physical health, possibly exacerbated by human interactions as well as climate change. Continued serious injury and mortality from vessel and fishing gear interactions. And we're also concerned, and they identify concerns about emerging industries like aquaculture, wind energy development, and other emerging industries. So the challenges they identified that we're supposed to prioritize over the next few years are challenges related to finding more information about climate change and its potential impacts, finding more information about emerging risks, as well as vessel strikes and entanglements, which we were already, to a large extent, working on. As I mentioned, it's a really collaborative effort across many people. So while NOAA is legally responsible for developing the recovery plans, providing the guidance, making sure we're doing things that are required by the law, and implementing management under the Endangered Species Act, these other partners are a major part of it. We work very closely with states, other federal governments, including the DFO, even a little bit of tribal work, non-governmental partners as well. The recovery plan implementation is done with a team in our region. That team is mostly other federal agencies as well as the states and some of the scientists. The other federal agencies do things that can hurt right whales as well, and so they're part of the recovery team so that they can work with their agencies to do what their agencies can do to promote recovery. For instance, we have someone from the wind team on there. We're hoping that they'll take back right whale priorities to wind development planning. We work closely to manage the Atlantic large whale take reduction team. I'll be talking further about them. There's a North Atlantic right whale consortium I've already mentioned. It's a consortium of members who have agreed to they agree that this species is so important that they'll share what would normally be proprietary data and share it among themselves so it can be used to promote recovery. There is a ropeless consortium. I'll mention ropeless fishing as an alternative to areas where risk is really high and where the risk of an entanglement is really high, where we close those areas. And when there's a closure, fishermen can't fish. Ropeless technology is being developed now to give them an alternative to allow them to fish during a period that's otherwise too risky. And the Right Whale Consortium has developed a ropeless consortium that brings people together from around the world to talk about developing ropeless technology that's feasible in commercial fishing conditions. And then, as I mentioned, we work closely with the Canada Department of Fisheries and Oceans, as well as the Transportation Department, their transport people, to try and reduce impacts on that side of the border as well.
When are the closures in New England?
I'm going to go over those. Thank you for asking. You're anticipating. I'm going to talk a lot about, really more about the Marine Mammal Protection Act implementation than the Endangered Species Act. And I'm going to focus on entanglement and attempts to reduce impacts of entanglement. Under the Marine Mammal Protection Act, there's a program called the Take Reduction Program, and it requires us, when take is below a level that's considered sustainable by a population, it requires us to bring together a group of stakeholders to together work on developing recommendations that they give to NOAA Fisheries, and then NOAA Fisheries implements it as regulations. The Atlantic Large Whale Take Reduction Team is the largest of all of the take reduction teams. I think there are currently 6 active ones in the U.S. We've got about 60 members, and it's all the stakeholder groups. So this covers all the states on the East Coast, so we have a state manager from every state. That's one of the larger caucuses. It includes the Marine Mammal Commission, which is a governmental agency that provides oversight on marine mammal management. It includes the headquarters and Southeast region. It includes all of our fishery management councils, since we're talking about entanglement reduction, and those are fisheries managed by a fishery management council process and an Atlantic States process. But it also includes a lot of fishermen. Our largest caucus is the fishermen group. So there's 18 trap pot, either fishermen or representatives of fishery organizations. The Maine Lobstermen's Association has a member on it. The Maine Lobster Union actually has a alternate, so they're at the table, but only one of them can vote at a time. The Mass Lobstermen's Association also has a member on it, as well as, in both cases, fishermen from those organizations. There's also gillnet fisheries are also managed under this plan, and so there are representatives of the gillnet fishery on there as well. So altogether, we've got about 22 fishermen out of the 60 people on the team. And I mention that because we really can't solve the entanglement problem without fishermen. They know the gear, they know the target species and how to fish for them. They know the vessels, they know the environment more than any of the other people at the table do. We do have Erica and Amy are both take reduction team members, and we do have, let's see, I got to look that up. We have 6 conservation members Erica's part of, and 9 academic members that Amy's part of. So 9 scientists and 6 environmental organizations represented. The NGOs, some say, are representing the whale, just like the fishermen are representing the fishing industry. I don't know if Erica feels that way, but that's how I've heard some of them talk about it. So we bring them together. We bring the team together when we've estimated that the serious injuries and mortalities are exceeding the optimal sustainable population level. So it's keeping the animals, keeping the right whales from growing to the population they need to get to. For right whales, the formula for figuring that out is dictated by the MMPA, the Marine Mammal Protection Act. And for right whales, the allowed or the sustainable level of take is 0.7 per year. So that's less than 1 a year. less than 2 in 2 years, about 2 in 3 years by serious injury or mortality. And in recent years, as that chart indicates, we've had, estimated takes of up to estimated mortalities and injuries of up to 30, of which some proportion is caused by entanglement. So when a stock has had its take level exceeded, we bring the team together, and we try to get to consensus. We have facilitators there that try and help us get to consensus. It's usually a very iterative process. We meet again and again and again, which is particularly hard, and a shout out to all the fishermen who are members. Fishermen fish because they hate going to meetings and sitting in groups like this, and when we force them to work with us, not force them, but when we bring them together to work at this in this iterative process, it's really not their preferred way of doing business, and it's rough. And then they often have to take bad news back to their community, which is also really difficult. So again, it's their job to help develop recommendations, but if they don't, NIMS is ultimately responsible. As of 2021, working with the team, I talked to you about the problem with up to a third, we only see up to a third of the mortalities and injuries, and up to 2/3 we don't see. And we did not know how to estimate what was causing those, but we weren't allowed to ignore them. For smaller fisheries or smaller cetaceans, observers sees it, they can extrapolate how many are taken by the fishery. For these takes, we only see them if we see the whale going by with the gear on it or dead on the beach with an entanglement injury. So we don't have the ability to do that. So we were struggling with how to apportion takes or what assumptions to make about the estimated takes. We took it to the Atlantic Scientific Review Group, which are advisors to NIMS related to marine mammal stock assessments, and they said that we should look at the known ratios of vessel strike versus entanglement takes and apply that to all the estimated takes. So if we have 30 and we know that 50% of them were caused by entanglement and 50% by vessel strikes, we should assume 15 are entanglements. And then we talked to them about what assumptions we should make about whether they're U.S. or Canadian, and there wasn't enough information, so they wouldn't tell us. So in the end, our assumptions are, we give a range. Either 30% are caused by U.S. fisheries, 30, 40, or 70. 30, 40, or 50 is our assumptions, and then we provide the team with a range. So what we told them was they needed an 87 to 93% risk reduction, which is a huge challenge. We did implement regulations in 2021. And those regulations, we estimate, reduce risk by about 50%. That was targeted only at the Atlantic lobster and Jonah crab fisheries. Then we were going back to look at all the gillnet fisheries, the other trap pot fisheries, and the mid-Atlantic trap pot, including lobster fisheries, for next steps. If you look at what was done in phase 1, there's really only 3 things that the team could come up with. One is reduce the number of serious injuries by using weak ropes so the whales could break out more easily. The other is separate them by closing areas. So these blue areas were already closed. These green areas, one way offshore in Maine and one large area southern New England and one in state waters in Massachusetts were added, and seasons were extended. So a lot of waters are closed. So we weakened rope. We closed areas altogether. We also required them to put more traps between trawls so there would be fewer end lines. So we reduced the number of ropes. And those are really the main 3 steps we have. We use a tool that looks at the hot spots. It looks at where there are either a lot of whales and strong gear, or maybe hardly any whales but so much gear, and it identifies areas where we need to target. And when the team got back together, they were basically looking at the same types of measures. They were looking at ways of expanding the weak line requirements, expanding closures, across all these fisheries, and also reducing the number of lines by changing how they configured it. So these are some of the closed areas. I'll pass this around as well. These are some of the closed areas they were talking about us implementing. It was not a consensus, but you can see that a lot of closures might be coming down the road. Some of these are only 2 months long, like the one in Down East Maine. Some of them are 4 months long, like a large one in southern New England. And for that reason, well, and so Congress sort of put a pause on a lot of this with this Consolidated Appropriations Act, which found that the lobster and Jonah crab fisheries are in compliance with the ESA until 2028. So we have until 2028 to produce a rule and make it effective that does this large risk reduction. They also are providing funds so that we can accelerate research into these ropeless technology that would allow fishermen to get their gear up, which they already can do. There are ways for them to do that now, but also let other fishermen know they're there to reduce gear conflict. So that's an opportunity we have now with some funding that we've received from Congress that we hope to continue to get. And I think Erica is going to speak more to that. And I might have used up my question time with too much talking.
No, we definitely need questions.
So with that, I can take some questions, and I'll pass out a few more graphics of the closed areas.